Hello, welcome back to the channel. So today we'll be doing additional mathematics past paper, May June 2024, variant paper 13. As usual, you only have 2 hours to finish the entire thing, and page number 2 will be your formula list. And let's go. The first questions will be about trigonometry graph. So y is equal to a sine bx plus c. So let's see how do we solve these questions. Again, like I said, we always look for the things that is easiest to solve, and in my opinion, that is the amplitude. So look for the lowest point and the highest point. Okay, so look for the lowest point and highest point. So you'll find out that, oh, it's actually the lowest point is at minus -2. Okay, minimum is at -2. The maximum will be at 6. So -6 plus 2 divided by 2. And look for that middle line. Look for the equilibrium line. That's going to be at 2. So draw a line at y is equal to 2. Okay, so that will be your equilibrium line, right? Let me just write it, equilibrium line, and then note that your amplitude is actually two gaps here, so that will be 2 and 2, 4. Okay, same goes to here, 2 and 2, 4. So therefore, A will be equal to 4. And the second one that you can find easily, that will be your period, right? So next one, we'll be looking for the B. Okay, so note that this is a sine graph, so the formula to find the period of a sine graph will be 2 pi over b or 360 over b. Okay, and note that we can just pay attention to this part. Okay, and in order to find the period, you know that period is basically the angles needed to produce one complete cycle, right? So only here is 240. 240 will be over here. So note that how many gaps do you need in order to complete the remaining graph? 1, 2, 3, and 4. So you need 240 in order to complete the entire thing. So 240, just multiply by 4, and then you will get 240 times 4. You'll get 960. So just use the formula here, 360 over b. So note that you will have to use degree because the given domain is also in degree, right? So 360 over b is equivalent to 960. So therefore, b will be 360. Oops, clear all. 360 divided by 960. That's gonna be, can you convert this to fractions? 3 over 8. Okay, so that is for A and B. Now your equation is almost completed. Y is equal to 4 sine 3x over 8 plus c. So in order to find the c, which is the easiest one, so all you need to do is to just let, okay, when x is equal to 0, c, your y is 2. Y is 2, just replace all the values in the formula. So that would be 2, 4 sine 0 plus c. Therefore, since sine 0 will be equivalent to 0, so therefore your c will be just 2. So question number 2, solve the equation 3, bracket 2, 2x plus 1, okay, close bracket, minus 11, bracket 2 to the power of x plus 3 is equal to 0. Give your answers correct to 2 decimal places. So how are we going to solve these questions? But before we do anything, just have a look at this. So first, you will need to find a way to simplify this first. There's no way you can solve anything when it's still in this form. So this can be rewritten as 2 to the power 2x and 2 to the power 1. So just put a 2 to the power 1 in front as just 2. So this is a simplified version, right? And when you rewrite the whole thing, please write down the simplified versions. Okay, write it in. Plus 3 is equal to 0. So let, in this case, right, just multiply 3 and 2. That would be 6. 2 to the power of x minus 11. 2x plus 3 is equal to 0. Let 2x is equal to maybe y. Yep, we have to substitute a value, right? So that would be, and 2 to x will be y squared. And why is that? Because 2 to the power of 2x is just 2x multiplied together using rules of indices, which will give you 2 to the power of 2x as well, right? So 6y squared minus 11y plus 3 is equal to 0. Solve using quadratic method. So that's going to be 3, 2, and then minus 3, minus 1. So 3y minus 1 is equal to 0, or 2y minus 3 is equal to 0. So I assume you guys are really comfortable with quadratic at this point. Okay, so there's y1 is equal to 1 over 3, y2 is equal to 3 over 2. But are we done yet? Of course no. Since we are letting, okay, we are just borrowing the identity, we have to switch it back from y2 to the power of x. That is 1 over 3. So again, at this point, I think we will need some help with the rules of logarithm. So take log on both sides. Okay, just put LG2 and then LG 1 over 3. And same thing, just put LG 2x, LG 3 over 2. Now move the x in front, so x LG2, LG 1 over 3. And then bring bring the LG2 to the other side. So from this point onward, it's just a matter of pressing calculator and not to be careless. So again, where's the log here? Okay, I have to go to the functions and look for the log. Oh, that's pretty not convenient at all. 1/3, close the bracket, and then divide. Should I divide it by function log 2? Okay, so the first answer would be minus 1.58. Remember that we have to write our answers in 2 decimal places, right? So minus negative 1.58 is our answer. So x lg2 is equal to lg3 over 2. X is equal to lg3 over 2 divided by lg2. That's going to give us 3 over 2. Okay, and then divided by lg2. Okay, so your answer is going to be 0.58. Find the coordinates. Okay. Question part 3. Okay, question 3 part A. Find the coordinates of the stationary points on the curve y is equal to 2x plus 1 square, okay, multiplied by x minus 3. So at this point, we are expecting students to know the definition of stationary points. Okay, it's a point where the derivative of y with respect to x will be equal to 0. dy over dx is equal to 0. So it's a turning point, right? For this type of questions, first you'll need to find the x coordinates, and afterward use the x coordinates to find the y coordinates. So we have to do this by differentiating the entire thing, okay, by finding the derivative of the y. And students at this point, we are expecting you to know that we are not going to expand this, right? So just mark this one as u, mark this one as v, and we're going to use product rule since both u and v functions are technically multiplying together. So just do this. U is equal to 2x plus 1 square. U prime is equal to 2x plus 1. And 2 minus 1. With the chain rule, don't forget to multiply by the differentiations of the contents inside. So there will be just 2 and 0. So 4, 2x plus 1 is equal to, this is the u prime, right? So v is equal to x minus 3. V prime will be x. Sorry, it will be just 1, right? There will be nothing else. So the formula for product rule will be u v prime plus v u prime. So all you need to do is to just write dy over dx is 2x plus 1 square multiplied by 1 plus x minus 3 multiplied by 4 2x plus 1. Okay, and we had just, for the sake of solving, we just make it easier. So 4x minus 3 2x plus 1, and then you know that given the whole thing is equal to 0, so I wouldn't recommend you guys to write that. Just write it nicely in the next paragraph. X minus 3 2x plus 1 is equal to 0, and take out the common factor. Take them out. So 2x plus 1 will be your common factor at this rate. Take it out. 2x plus 1 close bracket, 2x plus 1 plus 4x minus 3 close bracket is equal to 0. Okay, let me just make a wall so that it looks nicer. 2x plus 1, okay, then whatever is inside the bracket, I'm just going to expand this one, so that will be 6x minus 2, sorry, 12, that will be minus 11, I believe, because 4x minus 12, so negative 11, so close is equal to 0, okay? Now, so in order to solve for x, I think we'll have 2, and the first x will be just negative 1 over 2, the second one will be 11 over 6, right? At this point, just write 6x minus 11 equals 0, or 2x plus 1 is equal to 0. Okay, so since we have both coordinates for x, now we just use the same, okay? You substitute x into y is equal to 2x plus 1 square, x minus 3 to find the y coordinates. So I'm going to do the first one. When x is equal to negative 1 over 2, let's just press it here. Oh my god, 0.5, close. Is it negative? Oh, I forgot the negative here. Negative 0.5, close bracket, plus 1. Okay, then square the entire thing, and then 0. Is this on the top or what? Okay, 0.5, negative 0.5, Desmos calculator, minus 3, close it. So y coordinates will be equivalent to 0. Okay, but reasonable, because since this is a 0, right? So negative 1 over 2, 0 will be the first stationary point. So we just have to tap in 11 over 6 into the calculator. So I'm just going to do it normally then. 11 over 6 plus 1. Is there a negative? No. Plus 1. Close square. Okay, so that's going to be this. And I just, the whole thing, multiply by 11 over 6 minus 3. Okay, so the y coordinates will be minus 686 over 27, and that will be your y coordinates. Okay, there you go. You'll have your 2 stationary points. So for question part B, we are required to sketch the graph of y is equal to 2x plus 1 square x minus 3. So it's the exact same graph like the previous one, but we can take note that at these 2 points, the graph is going to have a turning point, right? So first, okay, students, I would like you guys to check whether the coefficient of x to the power 3, coefficient means the number in front of x to the power 3 after expanding the entire thing, is it positive or negative? Actually, it's not hard to tell, okay? You can just simulate in your brain. You don't have to do the actual expansions, okay? The 2x with 2x is going to be positive, right? So the outcome will be positive, and then x minus 3 together, this positive, okay, multiply with another, x at the end is going to be positive as well. So since the graph is going to be positive, coefficient is going to be positive, so you know that the pattern of the graph will be going from, okay, low, sorry, like this, from the low to high. Okay, so that's how you can identify. And likewise, if it's negative, it's going to be, if the coefficient is negative, it's going to be like this. Okay, oopsie. It's going to go from a higher place to a lower place. So, but at this point, we are looking at this pattern here, from low to high. So mark all the coordinates because you are required to state all the intercepts. So you can just write, okay, when x is equal to 0, where is your y-intercept first? So just put 1 square and then 0 minus 3. So that would be negative 3. So 0, negative 1, negative 2, negative 3. I'm just going to mark it here. 0, negative 3. Okay, so that's one of the our y-intercepts. Now, the main part, when y is equal to 0, so you're going to have like, how many roots? 2 roots here at least. So x will be equal to negative 1 over 2 and x equal to 3, right? So all this will be your coordinates, negative 1 over 2 and 3, 0. So I can just mark the coordinates as well, 3, 0. You'll get 1 marks for marking all the coordinates, so make sure you do that. Oopsie, sorry, that's negative half, right? Negative half will be over here, negative half. Okay, so that is our coordinates. Now, how do we actually sketch the graph? You know, students, when we have like square here, what does it mean? Okay, when you have a square, okay, this generally means that the graph or the curve will gently touch the root once. Okay, so at this point, you'll be expecting, for example, the root is x equal to negative 1 over 2. So you'll be expecting that the graph would just gently touch it like once. Okay, so this is how it would look like, touches once. So since we know that our pattern is going from low to high, so when I sketch the graph, I'm going to use green. So I guess it will be like this, going up, and then we know that this is a turning point, and it's going to touch it once, and I'm going to sketch it down. Okay, so it's going up like this. Okay, low to high. So remember, this is where the graph will turn, because this is also the stationary point, right? It's where it will turn, and then show that all the intercepts on this graph in order to get full marks. Luckily, you guys are not required to state all the points, all the stationary points that we have here. Yep. Oh, I think we should, right? 11 over 6. Yeah, maybe let me just put it. 11 over 6, that will be, let's just make it perfect a bit. So this one will be, yes. Since we already found it earlier, right? Might as well just write it down because I don't want to lose any marks here as well. 11 over 6, and then 686 over 27. Is minus 686 lower than that? Minus 686 over 27. Oh, it's actually way lower. It's minus 25, so you will be lower than the intercept. So I guess we're correct. So just mark, make sure you have everything. And since we already found the lowest point, the turning point, might as well you just have to label them from here. Okay, so that's basically it. Write down the values for k, which the equations, okay, 2 bracket 2x plus 1 square, x minus 3 equal to k has exactly 1 solutions. So what do we mean by that? First, you have to pay attention to this entire thing here. You know that this thing actually refers to, maybe I should use a different color highlighters. This entire thing here refers to y. Okay, so y is equal to k. So we would like you to draw a horizontal line, a horizontal line where the graph will only cross the curve once. So definitely it's at this region here. Okay, I'll just show you the line, how it works. Oops, okay, let me just put it back there. Okay, so pay attention to the line. So if you have to find a region where it will only touch the curve once, because they mentioned that we can only have 1 root. So if you go above here, you'll notice that it's only cutting the curve like once, right? So what's the conditions in order to cut the curve only once? So at this point, your x, okay, since we're talking about the y, right? So what line do we have to draw? Y has to be surely greater than 0. So we need to draw a line at the region where y is greater than 0. So in order to cut the line once, okay, that's the first line. So y is equal to 0, surely it has to be greater than y is equal to 0. So we want this region, so y surely has to be greater than 0. And the other one, okay, we can draw is look at the line over here. So if we keep on drawing the line here, it will have more than one root, right? So keep going down. So if you were to go down, you will only cut the curve once. So again, another line that shows us where only exactly one root, it will be y is equal to negative 686 over 27. But since we want the region down there, so y has to be nonetheless less than minus 686 over 27. So two answers here. Y has to be greater than 0 and y has to be less than 686 over 27. So question number 4, find sigma to 0. Okay, so this is integral questions. 1 plus e to the power 2x and square dx, giving your answer in exact form. Of course, we're not going to solve when it's at that conditions, right? First, you will have to expand it first so that this thing can be simplified. Okay, so just expand it 1 and then 2 e to the power 2x plus e to the power 4x. Okay, so please get this correct. Thus, you can rewrite them as 1 plus 2 e to x plus e to the power 4x with respect dot dx. Okay, just write that down. Now, let us start off with the integrations. But before we actually start off, I would like to make sure that you all really know about how to integrate something like this. So, for example, okay, this is the formula, right, guys? So if it's a constant, okay, it's a number, so you can actually just put them outside, so it doesn't bother you that much doing integrations. Okay, that is not the main thing, but the integral, the exponentials, how are you going to integrate them? So once you integrate them, okay, remember the derivative of this, it's going to be divided and put into the denominator, and from that point onward you do nothing. Okay, so that's basically it, plus c. And we're gonna do the same thing here. Okay, so once we start integrating, the first term will be just x. Okay, so 2 e to the power 2x. Don't let the 2 bother you because the 2 is not the main thing to be integrated. So focus on the power 2x. So the derivative of 2x, the differentiations of 2x is going to be 2. So just put underneath there. Just put it at the denominator. E to the power 4x. Okay, same thing. Just put the 4 down there. Focus on the 4x. The derivative will be 4, and then this one will be 2. Okay. And after that, just close it. But the challenging part is not about the integrations, but rather than to write your answer in exact form, meaning you can't just press your calculator and then get the answer. Okay, so 2 and 2, it's going to be crossed out. X plus e to the power 2x plus e to the power 4x over 4 with the limit, upper limit as 2, okay, the lower limit as 0. So just put that in. Okay, first we'll substitute a number with upper limit. So let me just fix the Apple Pencil for a bit. Okay, so 2 plus e, okay, to the power 2 plus e for 2 over 4, close bracket, minus substitutions of lower limit, okay, e2 multiplied by 0 plus e4 multiplied by 0 over 4, close bracket. So 2 plus e to the power 4 plus e to the power of 8 over 4 minus 0 plus 1 over 4. There we go. So what do we have next? 2 plus e to the power 4 plus e to the power of 8 minus 4 minus, okay, these two together, it will be 5 over 4. Okay, so then 2 minus 5 over 4, there will be 8. 8, okay, 8 over 4. So, okay, what happened to my calculator? Okay, guess at this point, calculator will not be available, but I'll fix it after the next questions there. So 3 over 4 plus e to the power 4 plus e8 to the power 4. Okay, so I guess that's the only way you can write it as the exact form. You can't really do anything right here, so just leave your answer like this, and you're gonna get 5 marks, right? Alright, our calculator is back. So when e to the power 2i, okay, this question is about the straight line graph. So just testing you guys, how do you convert your non-linear graph to linear graph? Okay, that's basically it. So given that you'll always be given 2 points, but most importantly is when e to the power 2y is plotted against x to the power 3. So find y in terms of x. So again, you will need, since we're talking about straight line graph, so you obviously cannot run away from y is equal to mx plus c. Know which one is y, which one is x is the detrimental factor for this. So this surely will be a y, okay, against the x. Okay, remember it's always y against the x. So e to the power 2y is equal to mx to the power cube plus c. Now, what do we do here? We have to find the gradient using the point given, 6.4, 7.2. So m is equal to 7.2 minus 5 divided by 6.4 minus 2. Okay, let me just use this thing, 7.2 minus 5 over 6.4 minus 2. That's going to be 1 over 2, right? So just 1 over 2. So e to the power of 2y is equal to 1 over 2 x cubed plus c. So to find c, okay, we have to substitute the points. Of course, I won't be using the second one. I'll be using the first one, but either way, it works fine. So 2, 5. And remember, students tend to make the mistake where they would just put the x, just treat this entire thing like x and then just replace the x inside with the 2, then they cube the 2 and eventually they get the wrong answer because that is not the case, right? Remember, we adjusted the axis, okay? So all the 2 here is actually your x cubed, and then all the y coordinate here is actually your e to the power 2y. So just replace the whole thing with 5 and then this whole thing with a 2. So cancel out 5, 1 plus c, therefore c will be 5 minus 1, 4. Okay, so rewrite the equations. E to the power of 2y is equal to 1 over 2x cubed plus 4. Are we done? Not yet, because we have to find y in terms of x. So what are we going to do here? You have to take ln on both sides because you're going to put the y down there, right? So ln, bracket the entire thing. Okay, move the 2y in front. So since ln e is going to be like 1, anyway, so you can just ignore them. So plus 4, and then move the 2 to the other side, divide by 2, move the 2 down. So y will be, I think I've drawn too much arrows, it's going to be a bit confusing. Y is equal to 1 over 2 ln 1 over 2x cubed plus 4. Okay, that is going to be the final equations when you express y in terms of x. So for part B, find the values of x for which y exists. So in order to solve these questions, basically the word y exists means that, okay, whatever will not give you a math error. So you need something, you need your original equation just now, okay? So you know that within the logarithm, the whole thing here cannot be 0, right? Or you cannot have ln negative number, because ln negative number will give you math error, of course. And then also ln 0 will give you math error. So this is a proof that the function is not going to exist when it's below 0. So your conditions, you have to make sure that all the things inside, okay, all the things inside here, it has to be greater than 0 for sure. So what you need to do, just take 1 over 2x cubed plus 4, make it greater than 0. Okay, move to the other side, minus 4. Okay, then there will be minus 8, negative 4 times 2, 8. Move over, then just cube root the negative 8. X will be greater than minus 2. So only the conditions for you to not get a math error is to put any x value that is greater than negative 2. Question number 6. It is given that y is equal to ln 2x squared plus 1 divided by x plus 2, provided that x cannot be equal to negative 2. So how do we do this dy over dx? So this is a difficult one, but you know that you can label this, the top numerator, as a function of u and the bottom one as a function of v. And you know that since this is involving divisions, so we can actually use quotient rule for this. Okay, so by quotient rule, you should know that the formula for quotient rule should be v u prime minus u v prime over v squared. Okay, that's the given, and we should know that u is equal to ln 2x squared plus 1. So the u prime will be 1 over bracket 2x squared plus 1. But according to chain rule, you have to again multiply by whatever products is in the bracket there. So multiply by 4x plus 0. So that technically is just 4x. So you have 4x over 2x squared plus 1. Okay, so v is equal to x plus 2. V prime is equal to 1. So find dy over dx. dy over dx, just plug everything into the formula. So v would be 1 multiplied by the u prime, 4x over 2x squared plus 1, minus u ln 2x squared plus 1 multiplied by the v prime. Sorry, oopsie, I think I might have mistaken this. So we should put v in front first, right? So that would be x plus 2, my bad. Okay, and then multiply by 1 over the whole x plus 2 square. Okay, so they don't require you to simplify this. You can might as well just leave your answer like this. If they don't request for everything, don't waste your time. Just leave your answer like this. And I believe that you can't further simplify this anymore. Okay, so this will be it. Okay, now given that x increases from 1 to 1 plus h, find the approximate corresponding to the change in y. So you know the formula for corresponding, okay? For approximation, that would be dy over dx is equivalent to approximation of y over approximation of x, right? So given that x increases from 1 to 1 plus h, so the approximation of x would be 1 plus h minus by 1, that would be h. And now, by chain rule, we can basically just move the approximation of x to the other side. So to find approximation of y, we'll need to take the dy dx multiplied by approximation of x. So given that, we should always substitute the initial value of x, which is x equal to 1, into this jargon long dy over dx. So let's see, what do we have? Dy over dx is equal to 1 plus 2, and then 4 over 3 minus ln 3 divided by 3 squared. Let's see what do we have here. So 3, basically we can cancel that out. It will be just 4 minus ln 3 over 9. Okay, do we need to express our answer in a correct value? No, I don't think so. So now we have the dy dx where x equal to 1 is substituted. Next one, we just have to find the approximation of y, where we can take, okay, I'm gonna use the calculator here. 4 minus ln 3, okay, and then I'll just take the whole answer divided by 9. So that's gonna be 0.32237 multiplied by approximation of x, where it's just equivalent to h. So we have 0.322 h, and just express your answer in the 3 significant figures. Yeah. Next one, when x equal to 1, the rate of change of y is 3 units per second. Find the rate of change in x. So how do you do these questions? Alright, you should always remember the formula. Okay, so in order to find the rate of change of x, we could have used the formula for chain rule as well, dx over dt. Okay, so our function would be the two variables. The main variables are y and x, right? See, y and x. So you just have to put dx over dy multiplied by dy over dt. So they have already given you the dy over dt because the rate of change of y basically reverts to the dy over dt is equal to 3 units per second. Now, we have to find the dx over dy, but since we already knew that dx over dy, okay, up there, you see, and when x is equal to 1, we even have the exact value over here. Okay, this is basically the value that we'll be reusing again for these questions. But since it's dx over dy, so whatever you have written up there will be inverted. 9 divided by 4 minus ln 3. So it's the direct reversal of the previous one, where you just have to swap out the numerator and denominator. So let's go on. 9, 4 minus ln 3. My goodness, ln 3. So we will get 3.1019. Okay, it's a long value, so just leave it be. Dx over dt, finally, it will be 3.1019 multiplied by 3. Okay, multiplied by 3. So that's going to give us answer multiplied by 3. So we will have 9.305 9.31 units per second. So that is the rate of change in x. Okay, next one. This is a good one. A 6-digit number is to be formed using from 0 to 9. Okay, the 6-digit number cannot start with 0. This is important. And each number, at most, okay, you can only use them once. So this one basically means that there is no repetitions. Find how many of these 6 numbers are divisible by 5. Okay, so there are 2 scenarios here. What do we mean by divisible by 5? Okay, we have 6 numbers to choose from. Divisible by 5 means that the last number could be 0, could be 5, right? You just have to know the timetable. 5, 10, 15, 20, 25, okay? The multiplication of 5. So you will see that the number usually end up with 5 or 0. Okay, that's how you look at it. But for these situations, I'll need to split into 2 cases, 2 different cases. So we'll do casework for when the ending starts from 0 and when the ending starts from 5. So I split them into 2. Later on, you'll see the reason why we have to do it this way. So after we put 0, the 0 is pretty much fixed here. So we just mark it as 1. Now, how many more numbers to choose from? So we can choose 1 to 9. So technically, there are still like 9 numbers to choose from. So 9, P1. We just have to select one number and put it here. So let's say I've chosen 1. How many more numbers can I choose to put in the 4 columns here? So that would be 8, P4. Okay, since I already written 1, so there's 1 less number to choose from. So 9 multiplied by 8p4, 8. Wait, let's not use this way. 8 P4, that will be 1680 multiplied by 1. So let's clear everything here. 9 times 1680, that will be 15120 ways. But that's not it, right? We have to continue. Okay, so 6 okay, for 6 digits here, when we end with 5, okay, let's just end with 5, and this is pretty much fixed. And remember the rules that we cannot start from we cannot start with 0. So technically there's 1 2 3 4 5 6 7 8, and note that there is no repetitions for everything you do here, so no more 5. Okay, now you can only choose from the 8 digits. You just have to put 1 to put it in front. 1 1 2 3 4, okay, then P4. So how many numbers can you put there? So don't forget that technically you still have 0. So 0, 2, 3, 4, 6, 7, 8, 9. So out of the total 8, you only have to select 4. So 8 times 8P4. Okay, so 1680. Oh, and then multiply by 1. So we'll end up with multiply. Oopsie. Okay, this decimal is so hard to use. Times 8. 13,440 ways. So the total ways will be, just add up the numbers. So you'll get answer plus 15120. So 28,560 ways. There we go. Okay. Oh, part B. The number of combination. Oh, this is a good one. N plus 1 object is taken 13 at a time. So we'll be dealing with NCR clearly because this is combinations, right? And it's equal to 16 times the number of combinations of n object taken at 12 at a time. So it's our job to find the value of n, and we have to break down all the available information. So n plus 1 C 13 is equal to 16 times n object taken at 12. So how do we simplify this? Note that you have to use the formula NCR is equivalent to n factorial over n minus r factorial multiplied by r factorial. I believe this formula is given to you guys in the second page, so not sure about the latest one. Could be different, but this formula you should be able to use it, right? N plus 1 C13. So how do you plug it into the formula? Just replace every n there, so it becomes n plus 1 factorial over n plus 1 minus 13 factorial multiplied by 13 factorial is equal to 16, okay, n factorial over n minus 12 factorial, and then 12 factorial. Okay, let me just move this one closer to the left. There we go. So now n plus 13. Okay, I'll just try to simplify whatever I can here so that it looks much more easier. 16 n factorial over n minus 12 factorial, 12 factorial. So as you can see, this one and this one, they are the same. Okay, so it doesn't matter if you bring them to the right or to the left, they're gonna get cancelled out, right? So just cancel the complicated stuff. And since I don't like fractions, so I'm gonna move 13 factorial over to the other side. So the entire thing will look like n plus 1 factorial, 16, and then n factorial multiplied by 13 factorial over 12. So I just want you guys to realize that we can actually simplify this one, okay, using what we know from the factorial notations. 13 factorial actually means that 13, 12, eventually the number will become 1. So just multiply the entire thing as the number gets smaller. So 12 factorial, it will be 12 times 11, all the way until 1 as well. So if you divide, if you put 13 factorial over 12 factorial, okay, basically, okay, all the number behind it will cross out, and eventually you will only end up with 13, right? So this thing can actually be simplified to just 13. So n plus 1, and I'm gonna move the n to the left hand side, so it will look like n plus 1 factorial over n factorial is equal to 16 multiplied by 13. Let me just multiply this. It will be 208. So now what do we have? N plus 1 factorial. So we have n plus 1 multiplied by n plus n. Okay, n minus 1. Eventually the list will go on and on. N factorial will be n minus 1, and so on. So n plus 1 factorial over n factorial is going to be n plus 1 n minus 1 over this. And all the things will be cancelled out, and you're only left with n plus 1. That's how this entire thing you can basically simplify into just n plus 1. Okay, so n plus 1 is equal to 208. Move the 1 to the other side, it will be 207. There we go. Okay, the next questions. The line L, oh, look at the marks, weightage 7. The line L is a normal to the curve y is equal to 3 for x plus 6 to the power 1 over 2. So technically it means square root, right? At a point where x is equal to 2, the point coordinate minus 2k, where k is a constant, lies on L, and you have to find the exact value of k. So I'll just say this is a curve. Okay, I'm gonna remove this thing first. So this entire thing is a curve. Okay, let me just sketch it more or less. I don't care how it looks like anyway. So at the point where x is equal to 2, okay, and the point minus 2 lies on the constant. So okay, we have to just say this. The line L is a normal at point where x, let's just say the x over 2 is here, right? And then you know that normal, the tangent is here. Okay, this is the tangent, and the normal is more or less somewhere here. Okay, I'm gonna use the, or maybe we shouldn't use the same color. I'll use the green line to represent the normal. So normal, line L. And then they've given us that the point minus 2k, okay, I believe that it's over here somewhere, minus 2k, it's on the graph, on the line somewhere. Okay, we have to find this exact value. So before anything, we have to absolutely find the equation of normal. Okay, and we know that the equation of normal is actually a straight line, so we have to use the formula y equal to mx plus c. And this from this point onward, we should also know that the gradient dy dx at the point x equal to negative 2 is actually our gradient. Okay, gradient or tangent, gradient of the tangent at x equal to 2. That's what I'm referring to. Okay, so now we have to solve for dy dx. So given that one have y is equal to 3, 5x plus 6, okay, square root. So we have to do it dy over dx. So move the power, okay, in front. So it will be just 1 over 2 multiplied by 3, 5x plus 6, and 1 over 2 minus 1. By chain rule, okay, we should find the derivative from the inside. That will be 5, and then plus 0. So it will just be like this. So 15 over 2, okay, 5x plus 6 minus 1 over 2. Okay, but is that it? Of course not, right? So we would like to find the gradient at x equal to 2. So at x is equal to 2, dy over dx is 15 over 2, 5 times 2. Okay, I'll just write this down so everybody can see. And then let's see what we have. Just key it inside the calculator. 15 over 2 multiplied by 16. Okay, close bracket. Then minus 6 over 5. That would be 1 point. I need the fraction mode. So 15 over 8. That is our dy dx, right? Or should I say the gradient, the gradient of the tangent. So the tangent, okay, the pink line has a gradient of 15 over 8. Okay, m1. I call this m1, but you know that the relationship between tangent and normal is always related by m1 multiplied by m2, which will give you minus 1. So use that relationship. So we have m1 15 over 8 multiplied by m2, that is equal to minus 1. So therefore m2 would just be minus 8 over 15. Okay, so now we have the gradient, okay, of the normal line, which is 8 over 15. So we are going to continue to look for the equations of normal, and then in fact we know m at normal is negative 8 over 15. So y is equal to minus 8 over 15x plus c. But to find c, we need the point where the normal line touches the it's actually the point on the normal line. So in this case, we can't use minus 2 and k first, right? But we sure can use the point over here. So at this point, x is equal to 2. How to find the y coordinates? So find point on curve where x is equal to 2. So what is the y? So therefore, given that y is equal to 3, 5x plus 6, 1 over 2. So y will be 3, 5 times 2 plus 6, 1 over 2. That's gonna be 16, 1 square root. So you will have 3 multiplied by 4. Okay. Therefore, y is equal to 12. So we have two values, 2, 12. Okay, that is the point. Okay, 2, 12. Now to find c, we just have to use this. To find c, use 2, 12. So plug all the values in. So I'm gonna just use calculator for this. So move this to the other side. That's gonna be 12 plus 16 over 15. So that's going to be 196 over 15. So therefore, we have our equations of normal plus 196 over 15. And now we are going to use this to find the value of k. Okay. So how to use this to find the value of k? Know that we have minus 2 and k. Minus 2, k. Okay, just use this one. X and y, plug it in. K is equal to minus 8. Let's see. Minus 8 minus 2 over 15 plus 196 over 15. So see, what do we have? 196 plus 16. That's going to be 212 over 15. So divided by 15. 15 So we have k is equal to 200 over 15. I guess that's it. And question number 9 in this questions. Okay, question number 9. In this questions, all lengths are in meter and time is in seconds. So we have the equation of the displacement given to us in this form. So how to find the velocity given at time t? So remember that. So in order to go from s to v, so you have to find the differentiations of s with respect to time, and to go from v to a, you have to do dv over dt as well. Okay, so going from sv to a, you have to differentiate, find the derivative with respect to time. So here, given to us that s equal to 4t minus 4 cos 2t plus 4. So basically just look for the s over dt. That would be 4 minus 4 negative sine, okay, 2t. By chain rule, don't forget, whatever is on the inside the bracket, you have to multiply by 2, and then plus 0. So 4 is not going to give you anything, so might as well just don't write it down. Okay. So that would be 4 minus, okay, negative will become positive, so 8 sine 2t. That is your equations for velocity. Okay, part B on the axis, sketching. Okay, it's about sketching your graph. So technically, if you don't find your equations, you can't really sketch anything here. So, and it's worth a lot of marks. Okay, so make sure you guys really get the first part correct. Otherwise, I believe there is no error carry forward here. So you guys will be losing mark for not being able to get the first one and then the second one. So this paper is really punishing in a sense. So they've given us the domain from 0 to pi. So how do we do this? Okay. So first, there are a few things that we need to see to check whether it's a positive or negative sine curve. So this is a positive sine curve, so we can pretty much think that, okay, the pattern is going to be like this. Otherwise, if it's a negative sine curve, it's going to be the other way around. Okay, but we are looking at the positive sine curve. You know the pattern. And the second step is we have to find the period first. So within pi, okay, let's see how many cycles do we have. And clearly, we already have the value of b. Oops, what's this? B is equal to 2. And then when it's a sine curve, you know that the formula for period is always 2 pi over b or 360 over b. I'm using pi because the domain given here is a pi, right? So given that b is equal to 2, I have to find it. So my period is pi, meaning that within I will need pi in order to complete one cycle. So you can pretty much predict that my graph is going to be only one cycle, right? Okay. Last but not least, we'll have to pay attention to the amplitude. So v is equal to 4 plus 8 sine 2t. Okay, when it's a maximum scenario, the highest amplitude that I can get, that will be 4 plus 8. Okay, where sine 2t will basically become 1, and that is the maximum that I can get. 4 plus 8 is going to be 12, right? And then the minimum is going to be 4, where my sine 2t will be negative 1. So 4 minus 8, that will be minus 4. Again, like I told you guys earlier before, or maybe in the first questions, it's very important for us to find the equilibrium line. So 12 minus 4 over 2, that's going to be 8 over 2, and you will have 4. So on your graph, okay, maybe I should have make the 2, 4, 6, 8, 10. Maybe I'll make it smaller since it sketches it after all, right? 2, 4, 6, 8, 10, 12. So look for the maximum, 12, and then look for the minimum, negative 4. So draw out the equilibrium line. So that will be around here. Okay. Okay. Stating the intercepts in exact form. So I would recommend you to put coordinates, okay, on every part of intercepts on the graph. All right. And after that, since this is pi, so half of it will be pi over 2. So you might need to split up in order for you to sketch easily. So this is like 1.5, so 3 pi over 2. And you know the pattern is going to be here. Okay, I'll need to top the maximum first. Maybe I'll be using dotted lines. And then the minimum where it can go, it will be minus 4. Again, I'll use dotted line. Yep. So we pretty much have our layout ready. Now it's just our turn to sketch this. Okay, the highest point that the graph can go will be maybe should I use, what color should I use? I'm using green. Okay, so pi over 4, it will be at the highest point. Okay, and then this one will be at the lowest point. This one will be here, and then at pi it will be here. Okay, so draw out the sine curve. There we go. Okay, exactly perfect sine curve. But the most annoying part that would be you have to label, since we are required to state the intercepts, so we are required to state the coordinates over here. Okay, but worry not. Okay, you have to just simply substitute where v is equal to 0. So just solving a little bit of trigonometry. Okay, so when v, I'm going to move this one up slightly a bit for more spaces. So given that 4, okay, so this is why the mark they will give you as 5 marks here. So let me just quickly solve this one. When v is equal to 0, what is my t? So 4 plus 8 sine 2t is equal to 0. So 8 sine 2t, you'll be dealing with minus 4. Sine 2t, in overall that will be negative 1 over 2. So negative here means that you'll be playing around with the third and fourth quadrant. So the basic 2t, now I see why it's 5 marks, okay. Basic 2t, remember when you're taking basics, okay, please just put sine inverse 1 over 2 without the negative inside, right? So sine inverse radian 0.5. So that's gonna be, it's gonna be 0. You cannot have exact values. So 0.5235 dot, 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 okay. A lot of dots coming up. So 3, the third and fourth quadrant. So you will need to add pi to the basic at the third quadrant, and then at the fourth quadrant you need to take 2 pi minus the basic. So 2t. Okay, I'm gonna take the answer. Oops. Okay. So pi plus 0.5235. So that's gonna be 3.665, and then 2 pi is going to be minus 0.5235, right? So we have 5.759 dot dot dot. So both divided by 2. So let me just find out the first one. Divided by 2, that's gonna be 2.88, and the other one 3.665 divided by 2, 1.83. So our coordinates here, it would be 1.83 and 1.830, and then the other one here would be 2.880. Okay, and I think it's pretty reasonable, right? 3.14. Yep, that is basically what we have here. All you need to do is to just label them and then show all of your graphs here. Okay, next questions. Find the acceleration of p at time t. So you'll be, in order to find accelerations, class, you need to use the equation for v first. So v is equal to 4 plus 8 sine 2t. So in order to find a, you need to find out the derivative of v with respect to time. So dv over dt, the 4 will just become 0, and 8 sine 2t will become cos 2t. And with the help of chain rule, you're going to need to multiply the 2 again. So 8 times 2, that will be 16 cos 2t. So that is it, 16 cos 2t. Find the acceleration of p at time t. So you don't need to do anything, it's just time t. Find the times where the acceleration of p is 0. So when dv over dt is equal to 0, I believe that's what they are trying to imply, for 0 to pi. Give your answer in terms of pi. So we have the equations, a is equal to 16 cos 2t. So this is also equivalent to dv over dt. And then when our dv over dt is equal to 0, what exactly is our time? So cos 2t is equal to 0. So since we are using pi, okay, just remember this, class, whenever you're trying to find the basic, okay, when you're trying to solve cos, is the function of cos is equal to 0, it's always going to be 90 and 270, right? But you have to convert it to radian first. So 90 radian with pi over 2 and 3 pi over 2. So then everything you just have to divide by 2. Okay, that will be pi over 4 and 3 pi over 4. So we have to give our answer in terms of pi, and that's basically it. 2 marks. In an arithmetic progression, the first term is a and the common difference is d. The sum of first three progression of this AP is 42. So the sum of the first three is 42. Let me just write it down first. The products of the first three terms is 6,720. So show that a, bracket a plus 2d, is negative 480. So first, let's see what we can do here. Okay, so sum of 3. Okay, basically the formula for sum of n, let me just give it to you guys. N over 2, 2a plus n minus 1 multiplied by d. Okay, so since our n is equal to 3, so 3 over 2, that will be equivalent to 2a plus d, n minus 1, and equal to 42. Okay, so 3 over 2, 2a plus d, n minus 1 is, oh sorry, I should have written here as 2. Okay, so since n is equal to 3, I've forgotten about that. 3 minus 1, that is, let me just rewrite it again, 3 minus 1, so that will be 2. Okay, that is equal to 42. So multiply the 3 over 2 in on both sides, so you have 3a plus 3d is equal to 42. Okay, so next you just have to divide a plus d. Okay, make it smaller. So that would be a plus d is equal to 14, but we have to show a and bracket a plus 2d is equal to negative 480, but this is just one. For sure we have to use some simultaneous equation technique, right? Okay, let me just draw a partition here. So the second part is going to be, you have to make use of the informations. The product of the first three terms in this arithmetic progression is minus 6,720. So you know how to find the next term in AP. It's always going to follow this formula. Tn is equal to a plus n minus 1 over d. So term 2 is going to be a plus d, and term 3 is going to be a plus 2d. Then you just have to multiply a with a plus d with a plus 2d. And all overall, that's going to give you minus 6,720. And remember what we did earlier? A plus d is equal to 14. So just replace the entire thing here with 14. So a plus 2d minus 6,720. So move the 14 to the other side. It will be a bracket a plus 2d. And then just punch your calculator. 6,720 divided by 14. That's going to be minus 480. So there, you can show whatever they wanted shown. Hence, given that a is positive, find the values of a and d. So we would like to use this a plus 2d is equal to minus 480. Find the values of a and d. So how are you going to find the values of a and d in this case? So move in. Oh no. So for part 2, hence, given that a is positive, find the values of a and d. So how are we going to find this one? We have to use whatever we have previously. So given that a plus d is equal to 14, right? We can just make d as a subject. So this will be the equation for us to use later on. And using the one that we have proven earlier, minus a at 480. So just replace the d with plus 2, 14 minus a, close bracket, that'll be minus 480. So multiply the a, inside there will be a squared plus 2a, 14 minus a, minus 480, right? So a squared plus 28a minus 2a squared minus 480. So we can basically solve quadratic. I'm just gonna simplify everything. So that will be minus a squared plus 28a plus 480. So to make things easier, let's just make the a squared positive and everything else like the coefficient of a squared as positive to make it easier. And then do the quadratic. So for this case, let me try it out. 480 divided by 24. Is it gonna 480 divided by 12? Can I try? 480 divided by 12. 40 minus 12. Yep, that's gonna be it. So 40 plus 12. So a will be equal to 40. Wait, let me double confirm. 40 minus 12 is it? Yep, a is equal to 40. A is equal to minus 12. So you're gonna reject because given that a is positive, so the negative 12 will be rejected. Now, given that d is equal to 14 minus 40, so d will be 14 minus 40. That's gonna be negative 26. Okay. So we have our value of a and d. That's basically how we solve this type of questions. In the GP, in the geometrical progressions, so the third term is exponential 4x over 4, and the 10th term is exponential 11x over 512. So find the a, first term, and a common ratio. So at the end of the day, since 5 marks are given, so I'm sure you have to do something that is pretty much related to simultaneous equations. So term 3, the formula for GP will be a, first term, multiplied by common ratio, and minus 1. Okay, just use this formula. Term 3 is equivalent to AR square. So AR square will be exponential 4x over 4. That's the first one. And the second one, A, for term 10, it will be AR, 10 minus 1, that will be 9. 9 is equal to 11x over 512. So again, how do we solve this kind of problem? So we can pretty much just make a as a subject first. There will be e 4x over 4r squared. So that's going to be our first equations, and the second equation. Just substitute the first one into number 2. Okay, just substitute 1 into 2, where we will have e 4x over 512. Oh, that's a oopsie. Wrote it wrongly. 4r squared multiplied by r to the power 9 is equal to 11x over 512. So this one and this, you can basically simplify them as r, 9 minus 2. And I'll just move this 4, okay, to the other side, move it over to the right hand side. So the entire thing becomes 4, 11x over 512. And this is e to the power 4x. And I can also move the e to the power 4x to the other side. So it becomes 4e 11x over 512 e to the power 4x. And simplify further, I will have 4 over 512, that's gonna give me 11e 128. And note that since it's divide here, right? So we can pretty much play around with the power. So 11x minus by 4x. Okay, so you will end up with r to the power 7 e to the power 7x over 120. Okay, so the final step, just move this one over to the other side, so it will become e to the power 7x over 128, 1 over 7. So you can also rewrite them as 7x multiplied by 1 over 7 divided by 1 over 128 to the power 1 over 7. So the bottom one is going to give you 2. Okay, the top one just basically cancel off. You will get ex over 2 as your common ratio. Okay, but is that the end? Of course, we don't forget about your first term, a. You can just substitute a is equal to 4e exponential 4x divided by 4 ex over 2 squared. Okay, e4x divided by 4, and then e2x over 4, cancel this, then you have e4x multiplied by 1 over e2x, so the overall it will be 4x minus 2x, and be 2x. Okay, we'll look at question number 11. Solve the following simultaneous equations giving your answer in exact form. So there is no way that we can solve when it's presented to us in logarithmic form, so we have to do something. And notice that the base are actually different. So how do we switch the base? So just giving you a general formula, the base A with the index B. So whatever is on the index, you will place them, okay, change them to any base that you like, and just put the index on the numerator while the base at the denominator. Again, how do we solve these questions? Go for it. 8 log base 3x plus 12 log base 81y. Okay, I'm gonna, before this, I'm gonna switch out, I'm gonna change this 81 so that it becomes base 3. So log base 3y log base 3, 81, closed it, then this is equivalent to 5. And note that log 3, 81 can actually be presented in 3 to the power 4, right? And you can use the power rule to move the 4 in front, while when you have the same base and same index, that's going to be just 1. So 4 times 1, this whole thing will be simplified to 4. So log base 3x plus 12 log base 3y over 4, close this, and by power rule, okay, so 4, you can cancel out even further. So now you have log base 3x plus 3 log base 3 y is equal to 5. Okay, and by power rule, move all those things in on top. X to the power 8 log base 3 y cubed, that is equal to 5. Okay, now in order to combine all of them, we have to use the rules of multiplications on the logarithm. So log base 3 x to the power of 8 with y cubed, that is equal to 5. Now change this back to index form. How do we do that? Okay, write down the base 3. Okay, move the 5 to the other side, and which is equivalent to the entire index, just move it to the left. So that's going to be x to the power of 8 y cubed. Okay, so that's going to be your first equation. Rewrite them so that it looks like x to the power of 8 y cubed is equal to 3 to the power of 5. Okay, don't do anything yet, leave it just like exactly just like that. I'm going to create a partitions for us to do the next one. So same thing, I'm going to have to change this one to base 3. So 4 log base 3 x log base 3 index 9 plus 3 log base 3y, which is equivalent to 2. And the whole thing can be simplified to log base 3 3 squared, so move the 2 in front, then you're going to end up with just 2. So 4 log base 3x over 2 plus 3 log base 3y is equal to 2. Cancel up. So by power rule, move all those all the coefficients back to the power. So log base 3y cubed is equal to 2. Now combine them using rules of multiplication. So we have x squared multiplied by y cubed, that is equal to 2. Change them back to index form. So we have 3 squared is equal to x squared y cubed. So now let's make everything equivalent to y cubed. So x squared, hold on, it should be 3 squared over x squared. Right? And while for the other one, it should be y cubed is equal to 3 to the power of 5 divided by x to the power of 8. So now we can basically equate them. Okay, so equate them, so that would be 3 to the power of 5. I'm going to use a different color here. Let me check. Okay, let's use green. So 3 to the power of 5 x to the power of 8 is equivalent to 3 squared x squared. So what do we have? So you end up with 3 to the power of 5 divided by 3 to the power square. Okay, then x to the power of 8 over x squared. Continue. There will be 3 to the power of 3 x to the power 6. Then move this one by the rules of reciprocals. There's going to be 3 over 6, and you're going to end up with 3, 1 over 2, or square root 3. Next, y. In order to find y, you only need to substitute the x into either 1 or 2. But let's choose the easier one since this is just x squared, right? So y cubed, that's going to be 3 squared is going to be 9 probably. But I'm not gonna simplify it right now, so there will just be 3. Okay, 3 to the power, since it's square root, so it's gonna be 3 to the power 1. Then cancel out 2 minus 1. You are gonna end up with just 3. But don't forget, by the rules of reciprocal, it's gonna be 3 to the power 1 over 3. Or you can just put it as cube root. Question number 12. So another annoying questions here, where you have to give your answer in exact form, but and it's 5 marks worth. But I guess this is not too bad because it's only secant 3 theta minus pi over 2. So of course you can't press secant in your calculator. If you can, that would be a different thing, but I don't think that kind of calculator is allowed in your examinations. So what we can do here, okay, you should, at this point, students should be aware that secant x can actually be converted to 1 over cos x, right? So you just use this identity and then just fix that, replace the secant into cos bracket 3 theta minus pi over 2, okay, which is equivalent to 2. Now, let's rearrange the places. That will be 3 pi over 2 is equal to 1 over 2 right here. And remember, we should set our calculator in radian mode because all of these are given in radian. So plus first and the fourth quadrant, okay, because cos will be cos positive. It's in first and fourth quadrant. So remember your quadrant stuff. Add sugar to coffee. So first, second, third, and fourth. And then the rotation is always going to be anti-clockwise. Okay, so we'll be dealing with angles in the first quadrant and also at the fourth quadrant here. Okay, from here and all the way rotate until here. So now let's find out our basic. The basic 3 theta minus pi over 2 is cos inverse 1 over 2. And remember, if you have negative, don't bring it when you are looking for basic. Please don't include the negative sign. Okay, let's go here. Cos pi, I hope my calculator works. No, there's no pi, right? Let me delete it. This is 0.5. And there is no, apparently, there is no certs in this calculator. So let me just use the different variations. Just give me 1 second. So we have to set to radian, cos 0.5. So that's gonna give us like pi over 3. Pi over 3. Okay. Is there really no certs representations? Let me check. No, there's not. Okay, it's fine. Then make sure you don't activate complex mode. I think this is huge. Alright, cos theta equal to minus pi over 2. This will be your basic. So in order to find what's going on in the first and fourth quadrant, we need to, okay, take pi over 3 and then simply just take 2 pi minus pi over 3 in order to find the angles. But notice that we will also need to rotate the other way around. Okay, so when there's a negative domain, what do we need to do? So look at here, class. If there's a negative domain, you should always start to rotate, okay, the other way, the other directions. So in this case, the first quadrant will be here, second, third, and fourth. Everything will be entirely reversed. So since we're dealing with first quadrant over here, that will be here, okay, and then fourth quadrant will be here. So everything else in this case will be negative. So minus pi over 3, and also negative 2 pi minus pi over 3. So we have 4 angles, okay, while two of them, this one belongs to the anti-clockwise directions, and the other one is rotated reversely in clockwise directions. Okay, now let's see what we have. 3 theta equal minus pi over 2. That's going to be pi over 3. 2 pi minus pi over 3. 2 over 3. 2 minus 1 over 3. That's going to be 5 pi over 3. Okay, negative pi over 3. And I'm sure the other one will be negative 5 pi over 3. So we have to check. Okay, it's not done yet. Since this is minus pi over 2 over here, we just have to move over to the other side. So it becomes plus pi over 2. So 1 over 3, hold on. Let me just go here. 1 over 3. Oh, this plus 1 over 2, I believe. So this is going to be 5 pi over 6. And the other one, 5 pi over 3. 5 pi over 3 plus 1 over 2. That's going to be 13 pi over 6. Okay. So minus 5 pi, okay, the other one, this time it will be a little bit different. So it's 0.5 plus negative 0.5, sorry. 0.5 minus 1 over 3. I believe that's the correct one, right? So this is going to be pi over 6. And then negative 5 divided by 3. It's going to plus 0.5. Then you're going to end up with minus 7 pi over 6. But is that the end? Of course no. You have to divide everything by 3 in order to get theta. So 5 pi over 18, 13 pi over 18, 18 minus 7 pi over 18. So you have to check whether everything is within the given domain or not. The condition must be everything must be within negative pi over 2 and pi over 2. So pi over 2, that will give us pi over 2, it's exactly 1.57. So your value shouldn't exceed that one. So 5 over 18. 5 over 18 times pi, that's gonna be, let's see, 5 pi divided by 18, check the range, that's gonna be 0. Okay, so this one surely will be included. And the other one, 13 pi divided by 18, it's gonna be 2.26, so at the end this will be rejected. Pi over 18, surely this is gonna be accepted, right? Negative 7 over 8, negative 7 pi divided by 18. Negative, okay, so this answer is accepted. So after all, you have 3 answers here. It's minus 7 pi over 18, pi over 18, and 5 pi over 18. That's how you solve these questions. Alright, so we have come to an end of this entire paper. I hope to see you guys soon. So happy revisions and take care. Bye bye.